Can someone confirm me whether you can see my screen? You can please unmute and talk or just drop a message in the group.
Yes,
Yes.
we can see the screen.
Yeah, thank you. Thank you. Okay. So please don't see this number of slides and start panicking like I'll be teaching you so many things, something. So this is a PowerPoint presentation. So I made sure that let the slides be good. So that's why you are seeing 77. But trust me, it will be very interesting. You'll know many things while I'm taking the session. Okay, let me start the session. Uh, Hold on. Actually, here it's in India, it's trying to like it's almost night now. It's 6:35, 6:45. So you may experience the change in the lightning. So please hold on for that. Please don't feel bad for that. Okay. So today's topic will be professional career development in electronics engineering. What do electronics want? So this is the topic, and mainly I'll be telling you things the bridge between electronics engineers and electronics industry. So let me start introducing myself. By now, again, you guys know my name. My name is Harshini. I'm from Bangalore, India. So one thing which I really want to tell about Bangalore is located in South India, southern part of India, and it is the known as the Silicon City, Silicon Valley of India. If you try to just Google and ask Google like Silicon City of India, you will find Bengaluru in Karnataka. So it has almost all the industries, semiconductor industries, IT industries, many companies here. So I basically come from this place. And yeah, presently I'm pursuing masters in electronic engineering at University of Essex. It's in United Kingdom, and I have work experience in as a physical design and verification engineer at Intel Technology, which is located in Bangalore. So let me show you my company pics where I worked. So this is actually the entrance, the first photo which you are seeing is the entrance, and these are the buildings like SRR3 and SRR4. I used to work here. Like SRR3 and SRR4 are like there are different kinds of projects. So based on your projects you will be allocated in particular hub where to work. So there are buildings from 1 to 7, I think. Yeah, so this is where I worked. And I also pursued a course in physical design at RVVLSI Design Center, which is again in Bangalore. So, and before that, I completed my bachelor's, the undergraduate program at Don Bosco Institute of Technology, which is located in Bangalore. I pursued bachelor's in electronics and communication engineering. So I just want you to tell one of my favorite and one of my major project which I contributed to Intel was working on Dolby Atoms. I think has anyone heard about Dolby Atoms? If yes, can you please unmute yourself and tell me Dolby Atoms? I think I can give you example. So if you go to cinemas or theaters, the audio effect you get from the movie, the clear audio which you get from the movie, you'll be enjoying like, oh my God, everything is going on real here. You'll feel the real experience of audio. So I worked on one of the this project, Dolby Atoms. So obviously the tagline is hear the whole picture. It's not like you're watching a picture, you will hear the picture. So in future, if you guys go to some theaters or cinema and have a good experience of audio, just think that I have also contributed like 10% of the project. Yeah. So What does Intel do? I told you about my company. So does anyone know what does Intel do? Can someone answer? Or if you're uncomfortable, please drop a message in the chat. Can someone unmute and tell what does Intel do actually?
Hello, my name
Yes.
is Hassan Kasim.
Yeah.
Uh, Myself, what I know from Intel, they
Yes.
are producing microprocessors, and say for PCs, something like that.
Good. Yes. A good answer. Okay. I see answer a company that makes microprocessors. Good. I hope everyone has some idea about this. Uh, yes, they manufacture semiconductor circuits. So microprocessors are also known as like the basic terminology. We usually a technical term we use as semiconductor circuits. Okay. So do you guys think there is only Intel which is manufacturing the semiconductor devices, or do we have other companies also? Yes or no? You can just tell me that. Just drop a message. Yes, there is Ryzen. Okay, good. Okay. Yeah, we have many companies which manufacture semiconductor devices. It's not only Intel. For example, Intel, Nvidia, Texas Instruments, Analog Devices, Microchip, AMD, Xilinx, all these companies are designing microprocessors. Even Qualcomm, Microchip, Intel, NXP Semiconductors, Broadcom. These are the top companies which are usually manufacturing the microchips. Okay. So now I told you these are the companies which are manufacturing semiconductors. So do you think semiconductor is really important in our everyday life? Let me show you one simple video based on this. And once I share video, someone please unmute and tell me whether the audio is audible or not. Let me play.
Let's think about the essential things in our lives. Water, air.
Can you guys?
Yeah, it's audible.
Yeah, thank you. Let me just maximize the screen.
Yeah.
Many things will pop into your head. What if all these things that we take for granted disappear overnight? Here's one more thing to add to the list. It is the semiconductor. If you don't agree with me and think semiconductors cannot be included with water, air, or family, let me explain it to you. How often do you think semiconductors are with you in your day? Let's follow Taisu's morning. The alarm rings at 6 a.m. Early birds would instantly wake up. Taisu barely wakes up after ignoring his alarm 5 times. Then he heads to the bathroom half asleep. The bright LED lights greet him. Taisu takes a shower, then carefully dries his hair with a hairdryer. Now he's preparing breakfast. After drinking a cup of water, he chooses toast for breakfast. He puts the toast in the toaster and drops a capsule into the coffee machine. He takes an egg from the fridge and fries it. Sunny side up is his favorite. After a quick breakfast, Darsu decides to take out his winter jacket from the steam closet because of a sudden drop in temperature. It's time to set off. Luckily, the elevator is waiting for him on his floor. Putting his Galaxy Buds in, he listens to a nostalgic pop playlist. He soon arrives at the subway. Darsu taps his transportation card and takes the escalator to the platform. It says the subway is arriving soon. He gets on board with great timing. Darsu walks to his company. He taps his ID card and directly shoots to his office using the elevator, arriving 10 minutes earlier than usual. It's a great start to the day. We follow through Darsu's morning. Did you find the semiconductors hidden in his morning? Let's count one by one. The firm's elevator, the company's entrance gate, his ID card, the automatic door, the subway information signage, the escalator, his transportation card, the subway gate, his Galaxy Buds, his apartment's elevator, the door lock, the steam closet, the induction range, the refrigerator, the coffee machine, the toaster, the water purifier, the hair dryer, the LED lights, and even the smartphone. At a glimpse, in total, it's more than 20. So there must be more that we missed counting. So, can you imagine living a day without semiconductors? We'll be back with more interesting semiconductors.
I think by this video now you might have like assumed that it is very difficult to stay without a semiconductor in a day. Everywhere and every gadget, semiconductors are used. So now, why should you work in semiconductor industries? You are attending this session and you might have this question like, why should you work in these industries? How are semiconductor industries related to electronics? What kind of jobs are available? How much do they pay? I think this is very interesting thing, which I'll be telling you. How much do they pay? And how to get a job in this semiconductor industry. So this will be today's contents of the talk. So I'll be covering all these topics. So let's start. So why should you work for electronics industry? Now, as the video we saw, semiconductors are everywhere. Again, one more point. If you want to buy smartphone, PC, or any electronic gadget, so what do you basically check for? Like, for example, you go to Amazon and you want to buy Samsung or Apple iPhone. So what do you usually check for? The basic thing. Can someone tell, or you can just drop a message? What do you guys usually check for? Storage, RAM, camera specifications. Okay. Yeah, that is very important, camera specifications. What else? Okay, let me show you. Basically I'll first check for the version, memory storage. Okay, we are getting answers. GPU, okay, good. Then we check for the operating system, battery consumption, power, speed, the graphics. So yeah, you might be seeing people like they'll tell, I have Qualcomm Snapdragon processor mobiles. My laptop is of Intel Core i6, i7, i9. i9 is the latest version. Like if you know there is a i9 or i10 users, you'll be like, oh my God, these guys are so rich. And this is NVIDIA, the GPU processors. So who are designing these things? Who do you think are designing these things? Let me tell you another example. Semiconductor chips for AI, neural networks, and IoTs. Nowadays, AI and neural networks is like booming. You can see autonomous vehicles like Tesla cars, smart home, smart city, like you want automatic doors, automatic AC, everything automated, medical electronics, like even in medical industry, we have many technology, media, agriculture, drones, and robotics. And I got an information that usually in UDSM, they're using Raspberry Pi processors for robotics. So who are designing all these things? Again, one more example. I told you like you guys are working on Raspberry Pi, and I know few of you are familiar with Arduino boards. So this is a Raspberry Pi, and can you see here we have a powerful processors, RAM. Do you guys think without these things, this Raspberry Pi will really work as a processor? No. Even in Arduino, there is something called microcontroller, Atmega microcontroller, which is very powerful. Without these controllers, processors, and RAM, it is impossible just by having these USB sockets, Wi-Fi. You can't actually work on these things. So microprocessors plays a very important role. Even in the semiconductor, like the military and defense purpose. So I think nowadays we are seeing this news like China military gets NVIDIA chips, and there is a book written called as Chip War, and even the vehicles are using semiconductor chips. So who are designing all these things? And I want to tell you one of the best example nowadays. I know there is a CAF Champion League going on in Tanzania. So imagine there is a match, football match between Simba and young Africans. So example, imagine there is a foul made by some of the team. We don't know who is that. And imagine like everyone is confused who. Like Simba fans will be telling, no, young Africans did this foul, and young Africans will be telling, no, Simba did this foul. So fans will be fighting. So what happens? Then there is something called as a new technology called video assistant referee. So they will be checking for the offside line. So even this has a microchip. So you guys daily you're watching football, and you anytime you get frustrated, you will be waiting for that one VAR video clip. So even that has a microchip. It has a powerful microchip where it can detect up to 500 movements per second. So it can record everything, what the player has touched the ball or not. So I think now you guys should really, I know Tanzanians, you guys are very big fan of your sports, the football, and hope you guys also get a chance to design a microchip for your football team. It will be very good. So what is, I told you, AI, neural networks, the military team, and obviously the football team. Everywhere we see the designs of microchip. So what is actually needed for this to design? First one, to design anything, obviously we need a circuit. Then to design this circuit, we need designers. Okay. So how these designers usually design? So we tell technology is growing, technology is growing. So what is this actually technology growing? It means there is a constant increase of the number of transistors on a chip. So can you guess which law is this? I think some of the final year students or someone know this, where the number of transistors on a chip gets doubled every year. Can you guys guess which law is this? I think you have studied this one. Anyone? Okay. This is called Moore's law. So I think you have studied about this for sure. You or else you will be definitely coming across this. So every year, the number of number of transistors on the chip will be doubling. Like this year, if you have 100 transistors, the next year you'll be having like 200, then 400, 800. So this is how the technology grows. So what is this known as? How can you increase the size of the number of transistors? How you can usually do this? It is very simple, that you just reduce the size of the transistor. In order to increase the number of transistors on a chip, just start reducing the size of the transistor. So how can you do that? So I think you have come across these MOS, the section view of the MOS, like you'll be having source, drain, and gate. So the distance between this source and drain is actually the technology, like 22 nanometer. And if you just start decreasing the size, decreasing the distance between source and drain, so that is how you can reduce the size of the transistors. So you decrease the distance between them, obviously the the size of the transistors get reduced. But if you start reducing the size of transistors, the circuit will become very complex to design. You see, technology is growing and you need to increase the transistors on the chip. You need to decrease the size. Complex, everything gets complicated. So everything is dealt by semiconductor chip designers. So whatever you are hearing daily that technology is increased, you have new chip, new. This is what is happening in the background. So everything is designed by the semiconductor chip designers, and they are needed, really very needed. So now we know what is trending in semiconductor industries and what they're doing, they're working on all domains. But how the semiconductors are related to your subjects, like to our electronic subjects. So I'll be talking about this now. So how you can generally relate your electronics theory to this semiconductor, what I gave you the examples of. So I think you guys know about this logic gates, buffer, AND gate, inverter, NAND gates. These are very the basic things of electronics. You guys know uh, the transistors, the diodes. So where are these used in semiconductors? Let's see. They are actually the final product of these things will be a semiconductor chip like this. But you know what? Designing the semiconductor chip is not at all easy. It's a very hard process. It usually needs all these steps to manufacture. But don't get panicked that I will be starting to explain you about all these things. No, I'm not doing that. I'll just tell you about each domain, what they do, and of course, each domain gets paid. And I'll be talking about the salary for this each domains. So be ready to know how much these guys are paid. And if you guys start working in semiconductor industries, now you know how much you will be getting paid. So get ready for that. Let me start with a simple example of digital alarm clock. Let's design a chip for digital alarm clock. So first, before starting anything, usually the semiconductor chip designers, they write down the functionality in a form of code for the electronics, and it is known as hardware descriptive language. I think you guys have heard about HDL somewhere. So there are three types of these, like Verilog, VHDL, and System Verilog. So the team which writes the functionality code for any of the design, they are known as RTL, register transfer level designers. So I'll give you, so this is the basic difference between software language and hardware language. So C, C++, Java, Python, SQL, these are software languages, and hardware languages are Verilog, VHDL, System Verilog, and these are basically used to describe the behavior of the electronic circuits, mostly the digital circuits. So I'll just give you a glimpse on how they write. I'm not telling you the big code, how to write VHDL. Just take example of an AND gate. We have two inputs and one output. Forget about the things which are in red color. Concentrate the ones which are in blue color, because these are just the keywords which you have to use no matter what. So this is an AND gate. Output is Z and input is A and B. So just we are assigning output A and B. It's just doing A and then it's just doing and then end module. So don't come to conclusion that this is very simple, but yeah, this is the basic thing. If you learn about this, then it's very easy to write complicated codes for complicated designs. Let's see, these are the screenshots on Intel career page. If you go, just you will find names like component design engineer, SOC design engineer, logic design engineer, hardware engineer. So these are in multiple locations. These are in Santa Clara, these are in Haifa, Penang, obviously Bangalore, Karnataka. It's like famous. You can see all jobs in Bangalore. So these are, I think everyone is very keen to work in Apple company where you have Apple phones, Apple laptops. Yes, there are 600 results, 600 plus openings for Apple company. So there you have RTL design engineer opening for in Austin, San Diego, St. Albans, Melbourne, RTL design engineer, RTL design everywhere, hardware, hardware, hardware. There is job openings, lots of job openings for these people. So now the very interesting topic, that is the salary for this domain. So it is approximately 3 million Tanzanian shillings per month for beginners and 10 million Tanzanian shillings per month for experienced people. So now you guys will be thinking, oh, Mungu wangu, hii ni pesa nyingi sana means, I know I'm still learning this language. Yes, this is what they are paid. It's huge amount. So yeah, if you get a chance to work as an RTL design engineer, the starting salary of you will be like 3 million Tanzanian shillings per month. And this, the experienced one, can go beyond this. I just put approximate because I have my seniors who are working for more than this amount of salary, like they're earning huge and huge amount of money. So next domain. So we are done with the first domain. Let's see what is the next domain and let's see what kind of package they are earning. So I told you that the example of digital alarm clock. Imagine there are two things happening in parallel. Time is also running and alarm suddenly rings. What if it fails? Example, take your mobile. You will be chatting with your friends telling that we'll go to party, we'll go to watch the CAF Champion League, that this, and suddenly someone calls and imagine your mobile shutdowns. That is not good, right? You will throw the mobile or you will start posting bad comments in the official website of the mobile telling that this is bad, that is not working, this is not working. So who will be dealing this? Here where comes RTL verification domain. So these RTL verification engineers, what they do is whatever the code written by the RTL design, they write the test cases for that functionality in Verilog or VHDL or System Verilog, and then they give you the verified code. So let's see one small example of AND gate again. So this is how they write code for AND gate. So we call it as test bench. So input is called as register AB. Output is termed as wire. And these are the inputs and outputs. We write it together. We begin. We test for all cases 0, 0, 0, 1, 1, 0, 1, 1, and end. In our design, we may only need 0, 1 to work. But what happens if 0, 0? What happens if 1, 0? What happens if 1, 1? It should work perfect, right? So this is where RTL verification engineers. Can you guys mute yourself? Since I don't have access to mute, please mute if you're not talking. Yeah. So I just I just searched for NVIDIA careers. So there will be something called as senior design verification engine. This is not only specified to NVIDIA. Even if you go to other company websites and find something called senior design verification engineer or verification engineer, it means that you will be doing verification. Senior chip verification engineer, design verification engineer. Yes, even in NXP semiconductors, we have something called IC design verification engineers, NPI design quality design verification engineers, internships in design verification engineers. So these are kind of openings you can see. And how much are they paid? They are paid approximately 8 million Tanzanian shillings per month for freshers and 18,000 18 million Tanzanian shillings per month. Are the jobs remote? Yes, of course, these are remote. Thank you for asking this question. I want to give you one good example. Like, example in Bangalore, if you just go out to the IT sectors and see, you see Samsung, Google buildings are like 16 floors, AMD 20 floors. They're competing with the floors. So it's not just to showcase that companies looking good or what. No, those 16 floors, 17 floors, whatever you can see, is you have design engineers there working day and night. So it is remote. So if you have doubt, like after the session, just go to each and every career websites and try to search for these terminologies: RTL verification, RTL design. There is openings every time. You can apply, but how to apply? Wait, I'll tell you at last. So this is a black box which I will be revealing at last, how to apply there. So yes, there are many people who is working, there are buildings, so many. There are branches also. Not only it's located in Bangalore or somewhere in USA, it's located in all parts. So imagine the number of people they require to design these things. Technology is growing too much. We need engineers for sure. So the RTL design engineers and RTL verification engineers, that together called as the front end team. So now in front end team, what's the output of that is like you get a code which works. What after this? What will happen? Is this code enough? No. This HDL code, whichever is written by the front end, it is converted into the gate level representation. Like I showed you the example of AND gate. You put input A, B, output Z. So that will be really converted into this kind of representations. So doing this, the people who work on these things are known as synthesis engineers. So the conversion of the HDL code to the gate level representation, they are known as the synthesis engineers. So this is an example of Qualcomm. So there you can see RTL synthesis engineer, senior level physical synthesis implementation engineers. This is from ARM. I think you know ARM processors, senior staff. Even DFT is designed for test. If you see this thing, just come to know that, yeah, this is synthesis engineers. Because if I start talking about DFT again, this is a bigger part of synthesis team, which I don't want to really explain it now because it takes one more session if I start explaining all these things. So graduate IP qualification engineers. So all these are the terminologies which you can start finding in the websites. So how much are these people paid? They are paid approximately 1 million Tanzanian shillings per month to 10 million Tanzanian shillings per month for experienced. So this is just approximation. If you get experience and if you do outstanding, the things will be out of roof, like you will be paid well. You can every month just go to Zanzibar to rest, have fun, then you can lead a very good life with this salary, I'm sure, pretty sure. So after synthesis, this is not done. Just having a gate level representation? No, there are things to do. You need to convert whatever the gate level to the layout, and you need to connect it, routing, and you have to give power supply for that. So example of an inverter, this is the schematic. This is just PMOS and NMOS. For people who don't know, maybe the first years, inverter is just they invert whatever the input. If you get 0, it will invert to 1. If you give 1, they'll give 0. So this is how it is represented in using PMOS and NMOS. This is the schematic. And I think few of the students here have come across stick diagram. So this is very important to learn stick diagram. If not, like in future classes, you'll be learning about this. So this is how the PMOS will be represented. They use P diffusion, N diffusion, metals. You learn about this. So this is the layout. And I just showed you the photos of this. But when you really work there in company and do this in a tool, this is how it looks. In Cadence tool, it looks like this. This is PMOS. You can see name here, right? PMOS. This is NMOS. This is input. This is output. Yes, this is how, forget about other things. They are really very technical. This is how it looks. And this is how the layout looks. I think you guys will be feeling this will be looking like somewhere garden and just having waterfalls in between. But yeah, this is how it looks. And this is how you will be designing in the tool. So next is pin-to-pin connection. Imagine like this is AND gate, this is XOR. You're connecting from here to here, and again from B to this input. You're just doing some connections, right? Between two different gates, or it can be between two different flip-flops, or anything else. So this is a small part, but if you really see in the angle of work, this is how it looks, the routing. It looks like a bird's nest, right? Yeah, this is how it looks. There are millions and billions of such connections inside this. Basically, I used to do this, and yeah, this is quite interesting also to do. Yeah, in reality, this is how it looks. The green and red lines which you see are this connection from here to there, there to here, here to there, everything. This is how it looks in reality. So next is, what if we happens like, this is the just top view which you are seeing, but when you try to connect more and more logic gates together, what you usually get? You get one memory. Like, for example, you use a basic gates and you try to connect them in some format which you will be trained in your company how to do that. So if you do that, you'll get a memory unit. The other thing, you'll get a simple circuit like AND, or some addition, subtraction, ALUs, something like that. So imagine this is like that. So basically we have two things, the memory unit and the other circuits. So this is how we basically align them: memory, simple circuits, input output pins, signal pins to the connections. And in reality, this is how it looks. The blue color which you can see here, they are the memory blocks: SRAM, DRAM, RAM. These are the memory blocks. And the tiny ant-like structures which you see, they are if you like maximize, and you see there will be very small, and that will be an adder. So this is like having trillions and thousands and millions of circuits together. So this is how it looks in reality while you are working. So you do all these things, and what if you don't give power connection? It will be something like North Korea and South Korea, where there is no power connection there, and it's just like nothing will be happening there. So this will be your memory cells and circuits, and you will start giving ground and power connections like this. And yeah, it's not only this much, like they'll be having plenty of such ground and power connections going everywhere to connect a circuit. And this is how it looks like in reality. It just looks like wafers. Yeah. So yeah, this is how it looks in reality. So these are the screenshots from synopsis. You'll get staff solution engineer, ASIC physical design methodology engineer. ASIC is application specific integrated circuit. Your chip is applied to only specific purpose, like only for VAR technology, only for Tesla cars, only for drones. So such ICs are known as application specific integrated circuits. So this is how the job title looks like. ASIC physical design engineer, methodology engineer, senior layout design engineers. Yeah, there's also one more thing which you can note down. Wherever you see layout design engineers, just imagine you will be doing routing and power connection, all those things. So how much do these guys paid? They are approximately paid 2 million Tanzanian shillings per month for the freshers to experienced. Of course, it will be going beyond this. It will be going beyond 12 million, but this is the approximation. Yeah, so these are the 4 major domains you see in the VLSI semiconductor designing department. So one is RTL, and one is RTL where design, RTL verification, synthesis, and physical design. And I showed you how much each of the department is paying. So how to get into this again still is a question. So wait for that. I just tell you how to get into these jobs. So this synthesis and physical design engineers, they are known as a back-end team. So now you know front end is design and verification, and back end is synthesis and physical design. So when you try understand the complete flow, this is how it looks. So front end people will be doing all these things, back end people will be doing all these things. But I really want to touch one more department in this design engineering, that is the timing part. So this is a separate department. So which will be dealing with the timing. For example, you have seen the functionality of your chip, your digital alarm clock working, you designed everything. But everything is fine, and what if timing goes bad? Example, what if the digital alarm clock rings at 10 a.m. instead of 6 a.m.? Imagine you have an interview in Apple company, you kept an alarm at 6 a.m. and when you wake up it is 10 a.m. You will be losing such a golden opportunity, will be losing such a valuable salary. So this is not bad. Even you keep alarm to watch your match, football match, and sleep, then you see that of course you will be getting updates from Instagram, I know that, but still watching in live and getting that spirit is good, right? So timing engineers are also plays in this semiconductor domain. So they are known as static timing analysis engineer. Forget about, I know this is complicated to remember, just remember like timing engineers, that's all. Why static, why not dynamic? You know, that is again a big vast domain. If I start explaining, you need one more session for that. So just remember they're known as the static timing analysis engineers. So it is just the technique to verify layout in terms of timing. You have layout ready, just check for the timing. You guys, timing engineers, they never check for the functionality. Functionality will be done by the back end and front end team. Timing engineers just concentrate on how the layout, how the timing works. So there are 2 main checks called as setup time and hold time. So this one, I know you guys will be coming across, and few of the graduated students or the ones who are at final year would know this setup and hold time. So this is like, usually imagine there is a complex circuit like this. You will be calculating timing from this path to this to this, again from clock to out, something like this. Like they are divided into different things, and you will be checking the timing for this. This is how it looks, the final product. So in Intel careers, so you will find something like STA engineer, physical design, STA engineers, STA lead, SOC static timing analysis engineer, SOC STA design engineer, something like that. And these guys are approximately paid 9 million Tanzanian shillings per month for the freshers, up to 20 million Tanzanian shillings per month for the experienced. So this is what they get paid. And of course, STA department is a very vast department. There are many people who will be working for this, because timing is a very critical part for any of the devices. Even your mobile just hangs on for 3-4 seconds, your Instagram hangs for 3-4 minutes, everyone will start panicking in whole world. And after 5 minutes you'll start seeing posts on that also, that oh, this one was hanged for this much minute. So yes, STA engineers are really very important, and yes, they are paid this much. So now, till now, you have the blueprints, like this is where the circuit should be, this is the connection. So now it's important to turn these blueprints into reality. For example, you have a floor plan for, you know how to build your house, like here I need a washroom, here I need bedroom, here I need living room, here I need kitchen. But how do you basically implement? There is a different department who are dealing with this. I'll just show you a small video on how they do what they do, but I'm not going to talk about this today because it's a different department whole again. So let me show you this video. Just I'll maximize the screen. Like I can give you a very small hint what they're doing here. So this is process where we design, you saw the final design right after STA, there is a circuit. So this is like using the laser technology, those circuits are printed on these silicon wafers. Yeah, so this is what is happening there. You may be thinking how those designs are related to this fabrication. So once you're done with the design and when it goes to the fabrication department, this is what they just like try to print your circuits on this silicon wafers. Yes, I saw someone just send me a message, photolithography process. Yes, this is correct. The printing of your circuits on the wafers is known as photolithographic process. And there is only one company which produce these machines, lithography machines, and this is located in Europe. It is known as ASML company. You can just go there and try to explore if you are interested. So yes, So now you guys know you are using your mobile, you're using your laptop, and the main thing which is beyond everything is the sand. So from sand you get the silicon, it's melted in some temperature to get this wafers, the cylinder. Then they're sliced, and using the photolithography process, they just print the circuits on the wafers and they chop, and this is how your circuit. So this was something which you saw here. One small block is your maybe digital alarm circuit or your microchip for VAR technology. Yes, this is how. So it's like they build house, like put foundation first, then put the pillars, then the process of building house. Usually fabrication team also does in a similar way. Once the design is exposed, first the substrate is formed, then all the silicon things gate. I don't know, like this takes you can try exploring about this, but this is another department. Designing department, fabrication department are two different domains. So this session was all about the design department. So fabrication department, since I didn't work on this one, I just wanted you guys to have the whole knowledge. And of course there is job openings for fabrication department also, and they will be paid approximately the same package as you saw for the design department. So now I told you all the process, how. So the question is how to get job there. Let me tell you that. So now you basically know whatever the circuits which you are studying in your in your UTSM or in your bachelor's undergraduates, they are finally converted into processors and controllers, powerful processors and controllers. So yes, these gates, you play with these things and you connect, interconnect, do that, do this, timing, everything, and finally you get these things. So this is really very important thing. Even if you want to program something, you want to run a Python code or anything, you need one hardware to dump your code and see the output. I'm not talking about the simulation things which you just run and find output, but if you are designing something, if you want to check how really that code works, you again need processors which can do these things and show you this is how they work. So microprocessors, controllers, and these chips, semiconductors, I can tell these are the heart of electronics, heart of the technology. So let's see how to get job in this semiconductor industries and what are they expecting from freshers like the undergraduate students. So let's go for the first one. Let's see what is the basic qualification they need. They need BE, BTech, or BSc in electronics engineering or electronics science or electronics and communication or electronics and electronics and telecommunication engineering. So wherever you see electronics, trust me, that is the basic qualifications you need. It should be BE. You can't tell that I'm done with my 10th, I'm done with my 12th, I studied about electronics, I want to get a job. No, you should be the undergraduate. If you do more than this, like do MS or PhD, that is also fine, but this is the basic thing you have to complete. And even computer science students, engineering students also can get a job here, but the thing is you should put a little bit extra effort by telling them that I'm really interested in electronics, because you see they are paying a huge amount of money, like huge amount of salary. So they need their employees to be like have some basic qualifications. They want you guys to know few things before you go into the industries, so that you will be eligible to get paid like huge amount of salary. So next one is technical knowledge. So even when I had interview, they didn't ask anything like, do you know this code, how Python works? No, they just asked me about Can you explain me CMOS? Can you draw the stick diagram? Can you tell me how flip-flop works? So these are the things they ask in the interview, because I face this. So you should have basic knowledge on logic gates, BJTs, CMOS, MOS, flip-flops. You should try to know the stick diagrams. These are the things which you'll be learning in undergraduate programs. And also, it is good to have basic knowledge on hardware descriptive language. That is, we saw Verilog, system Verilog, all those things, right? It's good to have this language. So how to get this knowledge? You should first concentrate on subjects like digital analog electronics, subjects which explain about basic gates. And HDL knowledge can be achieved by working on FPGAs. So FPGAs are field programmable gate you also have job openings for FPGAs. I'll be like, if you need, I'll be explaining you about this in future sessions about FPGAs. I can take one session only for FPGAs and explain you about that. So the next thing is, which is very important, is soft skill and communication skill. So imagine you just know the technical knowledge, but you don't know how to deliver it. Then it is really a very big problem to get chance to work. You know everything about logic gates, all knowledges you have, but you fail to present it to the interviewer or the company, then it is a big problem. So presenting your thoughts and your knowledge is very, very important. Okay, even I can tell you one of my exam, like one of my friend, he's very good in technical. Like, I have seen him working, I have been worked with him. He knows each and every corner of the, if something goes wrong in design, it's him which we usually approach. But since he was very poor in this presentation skills, he didn't get a job. But one of my other friends, she was like, she had good knowledge, but she was very good in sharing the ideas. Even if you just tell her what is AND gate, she can create a story based on that. So she was very good in telling stories and explaining simple things in a very good manner. So she got job. I think now she got job in Qualcomm. Yeah, she's paid huge, very huge amount just with 3 years experience. And the other way is to improve these things is to connect with people. Like, it's very important to have connections with people who are related to electronics industries, and also connect with the people who have good knowledge on electronics. So these people can help you to learn things, and if they feel you are good, they can recommend you to job. So example, if me and someone XYZ, imagine we both are friends, and someone comes to me and tell me that, Harshini, I really want to work on this department, and I really want to get job. Even if that is not my domain, I will feel that, okay, this, he or she is really very interested. Let me recommend to another friend, and I'll tell, hey, just see this girl or this boy is really good, just give him a job. So when you get experienced after 2 3 years, if you want to jump into companies, you should really have connections. Like, applying from websites is a recommended, but if you have connections, this is a very easy way to get jobs. Just have connections, go talk to them, tell your knowledge about electronics, make them feel that you really know things, and trust me, you'll get a job. So soft skills and communication skills are important. So other skills and certification, this is to make sure that your resume tells your interviewer or the company HR, showing that yes, this guy or this girl is very much passionate, How can you show them that you are passionate? Is by doing courses, certification courses. Like nowadays, you have Coursera, Udemy, NPTEL, LinkedIn Learning, etc. There are many online platforms which gives you knowledge about front end, back end, even RTL or physical design. Each one domain has different certification uh, courses. So please go to that if you're really interested. Just go there, try to do those courses. Those courses are not like you have to sit there for 24 hours and do. Like each day you can just spend 1 or 2 hours on that and just explore it and try to get those certifications. So the last step is to apply for internships and jobs. So how you can do this is prepare a good resume under the guidance of expertise. So you have all things, but your resume looks bad. No, because they will reject you, because that's the first thing which they see, how your resume looks and what are the things your resume contains. So prepare a good resume under guidance of experts. Make sure your resume contains related skills on electronics. Imagine you want to work for an electronics industry and you put something, SQL, data stack, stacking, that these things. No, that doesn't work. If you want to apply resume for electronics, write something about electronics, what you know in your resume. Don't mix up things. That you don't tell them that you know everything. Just tell them that you know electronics good and you want this job. So write a good resume. And the other thing is create profile in LinkedIn, Indeed, Reddit, and update all the details which are asked in this portal. Like no need to go for premium. I see few of them think that LinkedIn only works if you have the premium paid version. No, even I never took the premium membership. Just use a basic version. Try to update all the details. There is a different things about projects, your skills. Make sure everything is up to date and it looks good. And you can start following the company pages in LinkedIn. So I think you guys know LinkedIn is like they'll be posting, you have openings here, you have openings there. So when you start following companies like Intel, AMD, Rolls-Royce, Google, whatever it is, they will start posting jobs there if they have openings. So they'll post, we have openings in physical design engineer, something. If it is really important and if it is really urgent, they'll definitely post it in the portal. Then every company has their own career page. You can go there. Like for example, you want to work for Google, go to Google Careers, sign up, then filter jobs like ST or physical design or whatever it is. Follow the steps and apply. So this is how you can really do it and apply for jobs. Yes. So any questions till now? You can feel free to ask me anything. I hope you got some idea about your electronics engineering, how uh, I see someone is trying to talk, but it's not audible properly. Okay. Do you guys have any doubts or any questions to ask? Please feel free to ask any questions. I hope you guys enjoyed this, got some knowledge about our semiconductor industry. Any questions? I hope after this session, there are many people who wants to come up and tell me, I want to work here, I want to work there. Oh, everyone was well understood. Thank you, Elisa. Thank you for that. So hold on, guys, just don't leave. I want to really share one thing, that is obviously the feedback form. Yes, I'll paste this in. You can also come if you have more doubts, just I'll share you my profile, LinkedIn profile. Just go there and you can connect to me and you can ask if you have any doubts on this one. Okay. So please go to that feedback form and try to fill that. And you can connect me in LinkedIn. So yeah, I think that's all for today. Thank you. Professor, are you going to share these slides? This is a complicated question because these are confidential. But if you want, I can, cut short it like a notes, simple notes, and I will be sending these things to the boss, the Professor Baraka, and we have a group, right? So I'll be sharing that in. What is the minimum GPA to join Intel? GPA in India, like we are not familiar much about GPA. We are familiar with the percentage. So you should have 70% and above. But there is one more thing. You may get chances based on your resume. If you show them that, okay, you are good you have certification courses and you have some knowledge, even if your GPA, like if your percentage is 65, it works. It works because I have seen one of my friend got a job in Intel with 65% because, yes, programming logic controller in electronic field, PLCs. I am not something controllers. Yes, it could be. Maybe I will research about this and I'll let you know PLCs. Okay. Yeah. Anything else? If you have any doubts, you can just ask questions even in the feedback form, or you can ping me in LinkedIn or whatever it is. Yes, anything else? I'll just stay up to 5 more minutes. You can think and
Hello.
ask questions.
Hello.
Yes, hello.
Hello. Yes. Okay. I just wanted to say something.
Sorry, I cannot hear you properly. Can you be loud?
Yes. Can you hear me?
It's very low. Can you try to ask your question?
Hello?
Yes, now it's good. Yeah, tell me.
Yes, okay. So I was actually asking if we are going to have more sessions like this one in the future.
Yeah, you will have, like, if you open the feedback form, you will have such questions like, you can let me know if you need any particular topic to be covered or anything else. But yes, in future, I'll be having such sessions, more detail on each topic.
Okay, thank you. And the other thing is just I wanted to thank you very much for this session. It's actually eye-opening, like very, very eye-opening. We've been studying these stick diagrams and layer diagrams, and we actually don't know where they apply. And today you've showed us like there are jobs they pays well for these kind of things. Like I want to thank you very much because you
Thank
have
you.
really showed us like wow, so we can really be into this and actually gain from them. Thank you very much.
Yeah, I hope you guys got some motivation now to start applying for
Yes,
semiconductor industries. That's good.
yes, yes. Thank you very much.
Thank you so much. So, okay, guys, like, see you in next sessions. Thank you so much.
Just a moment before you leave, Hashin.
Yes.
Just a round of applause. I think thank you so much for this eye-opening session, and I believe students have enjoyed much. And I'm happy that some of the colleagues from my department, instructors, have joined. I'm seeing some of them, which I think now we are seeing ourselves what we teach, if really they are matching with what the industries want. So this connection between industry and we as instructors, I think it's a very important session. And I think we are going to have more of these sessions in future. So thank you so much for this eye-opening session, which I think should really, I recommend to continue. And Nelson, thank you so much for bringing Hashin on board. So we are seeing the importance of you being there at the University of Essex. Thank you so much.
Thank you, Professor.
Okay, thank you.
Thank you, Professor, for also giving me this opportunity. So even it's good for me to educate everyone about this. Yeah, I feel good now.
Okay.
Hello. Hello, madam.
Yeah, hi, Hassan. Tell
Hi.
me.
Also, I would like to say thanks so much for these sessions and for those students who want to visit in more sessions, want to join more sessions. I hope I can add them in a group. We have a group of career development in electronics. So after these sessions, I hope they will message me in my WhatsApp so I can add them for the future sessions. And also, I would like to welcome them in our lab, 3D and robotics lab here in our university, College of QIST. So if there is anyone who don't know about the lab, I hope they will check us on QIST Gitonyama campus. Of course, we are here and we have a lot of sessions going on. So if anyone want to join more sessions, please check me in WhatsApp or contact the person who shared you this link. Thank you.
Yes, thank you, Hassan. So I hope I'll get more sessions to do. And once I think I can visit your university once and meet everyone there.
Okay, okay. Thank you.
Yeah. Okay. Thank you all. Have a good day. Take care. Bye.